Problem says a random sample of 84 8th grade students' scores on a national math assessment test has a mean score of 282. That is a sample mean that they're talking about. I can tell because they said here, random sample, 84. They told us how many students were sampled. So that's going to be our x bar then. X bar is 282. The test results prompt a school administrator to declare that the mean score of 8th grade students in the whole state on the exam would be more than 280. So that's their claim that they're making, that mu is more than 280, and we can write claim by that. Now, since what they're saying does not include an equals sign, what they're saying must be the HA, the alternative hypothesis, because HO has to go with equals. And so we want to write the complement of what was claimed. The complement of what was claimed is that the mean score of the students' tests would be less than or equal to 280. Alright, that's the start of it. Then we want to find that our population standard deviation was given, which means we would be using a Z approach and not a T approach. They give us the alpha in a tail, 0.03. It is a one-tailed test because we only use two-tailed tests when you claim that the mean is equal to something or not equal to it. You know, this is going to be a one-tailed test. So let's draw that one tail. The null is what the test is about. As long as the sample mean comes out low enough, that would be in agreement with the null. So anything that's over here is going to be the safe region we would not reject. Therefore, this is a right-tailed test where our rejection region is if our sample mean comes out too high, because that would go against the null. Null says that it's less than or equal to a certain value. If we get a sample mean that's really big, that would go against the null. Okay, since it's a one-tailed test, all of the alpha is going to be contained in that one tail. And we have to look up on a normal table, what ZC corresponds to that tail size. It turned out to be that if you go to the formula sheets, I'm just going to look in the standard normal table, and by default it tells me the left tail and the Z that goes along with that left tail. I see right here there's an area of 0.03. They're talking about this tail here being 0.03, and then apparently the Z that goes along with that is negative 1.88. But because of the symmetry of the normal curve, there must be an equal tail on the opposite side, which would have a Z of positive 1.88. So I can still use the normal table. I'll just switch the Z that I get to positive though. Okay, so the Z that I need for my problem is positive 1.88. Next, I need to calculate the Z star. That is the standardized test statistic. Then we can compare it to ZC. Formula is x minus mu over standard deviation over square root of n. So x bar, our sample mean, is 282. For the mean, when you do the test, you assume that the thing that they're claiming is going to be the middle of your curve. So we're going to let 280 be the mean for now, see how the test comes out. Alright, so we're going to put in a standard deviation, which is given to be 32. We'll divide by the square root of n. N was 84 students. Now, when you plug this into calculator, you want to be sure to use parentheses. I'll do 282 minus 280 divide by parentheses 32 over square root of 84. That's a good way to enter it. I get 0.573. So clearly my Z star is not in the rejection region. And so we want to state that. We want to make two decisions. A decision about the null, and then we want to make a decision or a statement about the claim, because the claim is not always the null, as we see in this problem. So when it comes to the null, I'm going to fail to reject it. My Z star was not in the rejection region. When it comes to the claim, it is a little trickier to say something appropriate about the claim. Since I failed to reject HO, I'm going to write to the side of it that I like it. Because it's like a double negative to say fail to reject, and it can really confuse people, you know? So it's just good to say it's something in easy to understand terms. I like HO. That means that I don't like the claim. And so I want to just be sure to say something negative about the claim. And so what we would say, there's a guide for how to say it. So there's four possibilities. It could be that your claim is HO, and it could be that you reject that HO. It could be that your claim is HO and you fail to reject HO. We don't have any of those cases right now. Our claim was HA. It's possible that we might reject HO. We did not, though, in our particular problem. We actually have this case right here. HA was our claim, but we, in our problem, failed to reject HO. Therefore, the wording that we need is, there is insufficient evidence to support this claim. So that's what I'm going to say. At the alpha equals 0.03 significance level, there is insufficient evidence to support the administrator's claim that the mean score of 8th graders on this math assessment is more than 280. Okay, so it's interesting that even though the sample mean came out to 282, it is not enough evidence from a probability standpoint to state that it is statistically significantly above 280. It could be if you were to raise the alpha level, make that rejection region bigger. But that means you're not as confident in the statement.